How are you, everyone? Good. I'm doing fine. Thank you for asking. Okay, so if you do not have any worksheet, you can get one here. And pass me your worksheet from last week. And then go right. Jannah's wearing do you know exactly what I mean? Question on it. Any more worksheets from last week? Okay. Did you guys already go over with difference quotient in your class? Did your lecture instructor show you how to apply difference quotient formula? Asking about question 2, sorry. Do you have an idea how to apply the difference quotient? Okay. Did the instructor talk about domain of the function? So you have the knowledge, right? So try it on your own. I mean, not on your own, you can try it with your friends, with the group or anything. Try that worksheet to do it by yourself first. And then if you have any question, I'll go over them on class. Okay? You didn't have to work alone. Talk to your neighbor, share your ideas, and no laptop, please. Close your laptop, close your phone. You think you have no idea what to do? Pick a person whom you think knows what's going on in the classroom. And then work with them. And if you really have no idea what's going on, pick one question from question 1. A, B, C, or D. I'll know about. Which one you think is harder or confusing? You don't have any worksheets. I have worksheets here. By the way, in your exam, there definitely will be one domain question and one difference quotient question. So something like question 2A and one of them from question 3. You will see in your exam. But you cannot multiply unless you apply your square color. Because PEMDAS is parentheses and exponent. So it is -1 square. Up to 1. And then you can multiply it. Yeah, but here it shows you multiply Q with -1. This arrow means you multiply Q with -1. So you should write this one here and then like this. So this is 1. So multiply Q with 1. Difference quotient. Watch it here. So difference quotient, it means we have to do three things. Either do them in 3 steps or do everything in 1 step. But there are 3 things we're supposed to do. Our first step is, this is 2A, okay? we need to find what is f of x plus h. This is step 1. And once you find f of x plus h, we are going to subtract the original function from the result. So this is our second step. Once we do the subtraction, whatever result we get, the difference, we are going to divide it by h. That's our third step. So let me do it step by step. Our f of x is negative x squared plus 2 times x minus 5. That was f of x. F of x plus h means where you see x, don't write x anymore. All those x replace with x plus h. Okay? Keep your structure same, and then you replace all the x with x plus h. So if you have hard time substitution, do the way I'm doing. Rewrite everything, just don't write x. Instead of x, keep writing parentheses for every x. Now let me change it to red. My x is x plus h. See, I did not write this x, I wrote x plus h. I did not write this x, I wrote x plus h. Because this is what substitution does. It replaces the x with whatever we want to replace with. And then we simplify. Square power means multiply the same thing twice. So you cannot actually distribute the power when you have addition or subtraction in the base. Instead, you're going to do x plus h times x plus h. If you don't know the special formula, if you do know the special formula, use the formula. Here, we are going to do distribution. So negative 2x plus positive 2x plus 2h, and this 5 has nothing to do, they bring it down. Now let's multiply this. How do you multiply binomials? Which method we use? FOIL. So tell me when you do FOIL, what do you get?
X squared plus 2
So we have xh, another xh, and then h squared that turn into x squared plus 2xh plus h squared. All of these are nothing to do, so we have to keep writing them. And then what happens? What happens to the negative in front of this thingy bracket? We need to distribute that. So every term you see inside your bracket or parenthesis, whatever, they will change their sign. So x squared is negative, 2xh is negative, h squared is negative. And again, all of these, we bring them down. That's our step 1. Substitute, simplify. Step 2 says, whatever you got it from there, subtract f of x. What is f of x? The original function. So f of x plus h minus f of x. So we write all of this down. I'm too lazy to write them down. So let me just write on the top and subtract f of x, which is negative x squared plus 2x minus 5.
I don't understand why you made negative x plus h squared a negative, because what I did when I distributed, I put the negatives inside the parentheses.
Did you hear about the expression PEMDAS? PEMDAS. What P represents? What E represents?
Exponent.
What M represents? What did you do? Which one you used first? Are you allowed to use multiplication without using those? So you cannot distribute. Okay? It says exponent. So x plus h squared. We have to work with the square first. That's why we FOIL them out, because squaring means FOILing out. You're multiplying the same thing twice. And then we multiply the negative. So exponent and multiplication. First exponent, then multiplication. Okay, so as I was saying, I'm too lazy to write the whole thing down. So instead of the whole thing down, this is f of x plus h, and we are subtracting the original function. But when you subtract, what happens to the signs? They change, right? That means now I'm going to write all the things. Negative x squared minus 2xh minus h squared plus 2x plus 3h minus 5. And I'm subtracting. So negative and negative will turn into a positive x squared. Negative and positive will turn into, will turn into a minus 2x. Negative and negative will turn into a plus 5. That's why I put parentheses around my f of x when I substituted. So f of x plus h minus f of x. Anytime you subtract more than one term, you must put parentheses. If you forget that the sign will change. But if you already know that the sign will change when you subtract, you don't need the parentheses, just write it down with the changed sign. And now simplify. Do you see any like terms to combine? What can you do here?
Negative x squared and
Cancel out. Anything else? 2x and negative 2x. 5 and negative 5. So what is left then?
Negative h squared minus 2xh plus h plus 2h over 8.
Plus 2h. So that was our second step. Third step says, whatever you have, divide that by h. Well, I'm going to divide, but before that, can you pull out anything here as a common factor? Negative 2x minus h plus 2. So this is what do we have for the second step. Now in the third step, whatever, let me check the color so you can see. The third step is whatever you found in the second step, divide that by h. So these are step 2, these are step 3. What happened? And that was our step 1. So in the second step, we found the result is h times negative h minus 2x plus 2. We are dividing the result by h. And then what happens? What do you see? Can you simplify anything here? H. We can cancel them because one h is multiplying on the top, another h is single on the bottom. Cancel. And let me rewrite with the plus on the front. So 2 minus h minus 2x. You don't have to rearrange. I just rewrote because I want to start with something positive. Why is the eraser here? Who is confused? Anyone needs any part to be explained?
Will you always look for a common factor or something?
Anytime you see a common factor, pull it out. Because our goal is at the end, we don't want the h on the denominator. So remember, in your exam, you have to do at least one of them. And then when you take calculus, you're gonna use it, you're gonna use this a lot. Because this is actually the definition of the derivative. If you put a limit in the front, it will become the derivative. So this is a very important concept. And in the exam, they're going to ask you something like this one. A. B is easy, but a little bit more work. Because you have to take LCD and then simplify, keep, change, flip. So it's easy, but takes time. This is simpler. You don't have to do any LCD or anything. Any question on this? Anybody has any question? No? Are you guys done with the domain part, domain question? No? Okay, try the domain question, and if you get stuck, I'll do one of them.
So for my last month, like, it's like a weird denominator.
And then you're gonna do the same thing here.
With,
So you need LCD, right?
Yeah.
What's the LCD here? No.
plus,
So if this is the LCD, then what I'm going to do is 2x. So LCD is like a big thing. That big thing you can divide by all the denominators. So if you think this is your LCD, can you divide this by 2x evenly? No, because you're going to get extra 2h left, right? So this is not LCD. How about this one? Is this LCD? Right. You cannot divide this by this whole expression. So when you have nothing, like you cannot divide one by another.
I don't see that, but it's like,
Go down now. Thank you. Get that? Almost fine.
Oh, yeah, yeah. That was.
oh. Yeah, and then, so that's, and then it's the line and the original, it goes back to the, but it can be that. One of that. One of the one. The third line here is 17. Yeah, so this is, and you can hear it. And then you have to subtract this from one of the two. But I already know. So I don't know how to get from here.
Now they have. Nothing.
And I have to find something.
And that here, and this.
And then
Also, we will follow the limit. The same problem that. Yeah, this is part of the denominator. So there is the same thing for the denominator. But this one is completely different. It's another part inside the square root and then another. There is one. You can close the two from here, right? And then you can how come the first four and three? So yeah, you can close the two and you can put this two this time. Can you take zero? Can you have zero on the numerator? Number or any number. Right? That's can the numerator be equal to zero? And then see both of them, so which part of the number line was function. Okay. That's good. Now we have that and never be good. Because you don't know how to divide by very strong in my computer. Not X, I'm talking about X.
No.
X and is zero. But I'm talking about X is I'm talking about the whole denominator. Whenever I have a whole denominator, one click only once on the entire denominator. What makes the denominator zero? That number is zero. And then I'll begin with that anyway. You want to get a use. What do you think we grow out in public tables? That will be great. How many? Go ahead. Start with you. You leave it. You immediate lever.
I just want to remember the right time. Yeah.
And then you can pull up an H, one of them to H. There is an H there, right?
Or it's or the whole six are.
This is what is happening here.
Yeah.
The 2x squared.
Four X.
4x.
I have it here.
Oh,
It's just
okay.
sorry. I
You
can
can-
write like it's
And
and then so would it be
this is wrong. This H has invisible one. So this is one fraction and this is another fraction. So keep change rate. It's an H over one plus one over.
I thought it was original. So it's okay.
Because
I
we have a
thought
fraction
this
on
would
the
be the
top.
one.
Exactly. So this is one H. And another, so this is like one, it's one
So it's the other
fraction.
way around.
Mhm.
Okay.
It's one fraction. So you keep the numerator fraction. But leave the denominator. Step is correct. Second step is correct. And now we.
Why did you change? It's a plan.
Oh, this step is. This reacts. Here to.
Yes. You can just put your time.
And
But
then
it's
you
not
put the
used by
parentheses.
each other. So this
So this is right, but this is not. Why not? Because
That's why it's not.
when it is what you do.
You know how it's over eight?
Yeah.
I mean, the numerator is the one, but apparently it's not over each over one.
Let's cover one domain. Is, you can have harmony, you can combine. Okay, let's go ahead.
Yeah.
I can see following my morning. Okay, if you're already done, you know what to do. If you're not done, no problem. Let me show you what to do. Good news, this will not be in the exam. But still, it's better to know how to solve something. So we are going to do the same thing. First step, find out what is f of x plus h. So 1/2 times, instead of x, we are going to replace this x with x plus h.
Oh, do we take first?
If you want, you can keep it, or if you want, you can distribute the 2. So it becomes 1/2x plus 2h. Second step says, whatever you got in the first steps, subtract the original function from there. Okay, we found 1/2x plus 2h, and we are going to subtract the original function, which is 1/2x. And then all of you get stuck, right? Most of you get stuck. Well, it's easy to get stuck because we don't see what to do next. When you see nothing what to do next, it means you have to deal with it. Somehow you need to combine the two fractions into one fraction. So, hardest part, figuring out what is our LCD. I need more space, so let me just get subtracting 1/2x. LCD is a big thing. That big thing, we can divide by 2x plus 2h. Also, we can divide by 2x. So what is that big thing? Will we see if one of them is multiple of the other one? Of course not. We cannot multiply 2x with something and becomes 2x plus h. If one is not a multiple of the other one, that means to find the LCD, we take all the denominators. So our LCD is both of them, 2x and 2x plus 2h. But if you want to ignore the 2 writing twice, you can also do that. That means we need to multiply this expression by 2x on the top and bottom, and need to multiply this expression by 2x, 2h, top and bottom. Now we see both denominators have the same thing, 2x times 2x plus 2h. So we write the denominator once and we combine our numerators. 2x minus, since we are subtracting the second numerator, so this positive 2h will turn into a negative 2h. So negative 2x, negative 2h. Positive, negative 2x cancel out. We get negative 2h over 2x, 2x plus 2h. We can cancel this too, because the denominator 2x is a multiplication with the next term, and numerator 2 is a single 2h. So we left with negative h on the top, x and 2x plus 2h on the bottom. So this is what we have in the second step. Now the third step says, whatever we have in the second step, f of x plus h minus f of x, the whole thing divide by h. So we have negative h, x times 2x plus 2h. We are dividing this by h. But now we are dividing a fraction by something. So you're going to keep this fraction, change that division sign into multiplication, and you're going to flip the h. If you flip h, what it will become?
1/8.
1/h, because this h has actually invisible 1 below that. So when you flip a whole thing, it becomes a fraction. So we keep -8 over x times 2x plus 2h. We change the division into multiplication, and the h becomes 1/h. What happens next? We have h on the top and h on the bottom. You can cancel them. Anytime you have something on the top, same thing on the bottom, and we have a multiplication between the denominators, then you're allowed to cancel. So you're left 2x plus 2h on the bottom. And what do we have on the numerator? What is left? We canceled everything. We have a negative sign. And when you have nothing, we have a 1. This is our final answer. Sorry, final answer. So subtract, simplify by taking LCD, and then divide by it. Okay? Was any step unclear to anyone?
Yeah.
If you want to keep it, keep it. You don't have to. Or if you want to pull out a 2, you can also pull out a 2.
So the two
They both have different denominators. But we want to have a single denominator by which you can combine both of them. So just combine them. We took both of them and we said, oh, that is our LCD. Okay, the last question is about domain, and domain is what x values you're allowed to substitute in the function. So depending on your function, you observe what's wrong with the function. Let me go over B because it has 2 restrictions. One is on the top, one is on the bottom. So if you look at on the top, we have square root of x minus 3. What we cannot have inside a square root? What type of number we cannot have inside a square root? Negative. We can have a 0 here. If you have a 0 on the top over a number on the bottom, it's 0. So a numerator can be 0. And it must be bigger than 0. Because there is no way we can have a negative inside the square root. Square root. It means find a number, multiply twice, and you get whatever you have inside the square root. So when you multiply a negative twice, it becomes positive. If you multiply positive twice, it becomes positive. So there is no number when you multiply the same thing twice, it turns into negative. Thus, you cannot have any negative results inside the square root. So we take the expression inside the square root, and we said, well, this expression must be bigger than 0, means positive, or it can be 0 this time because of the numerator. But the same square root, if you put it on the denominator, then you have only one condition. It looks like upside down 6, sorry, flip 6, 0. So for A, our condition is that thingy has to be bigger than 0. But when you have the same square root in the numerator, we are allowed to have 2 things, 0 and also bigger than 0. Now solve for x here. To solve for x, what do you do? If you want to get the epsilon, we need to get rid of the 3, right? How? Add. So if we add 3, we get x is bigger than or equal 3. So this is saying if you have a 3 here, you can put 3 in a function and you must put everything bigger than 3. I mean, not must. You can put anything bigger than 3. You can put 3, 4, 5, 6, 7, 3.5, 3.1, anything starting from 3. And you can use 3 because 3 minus 3 on the top gives you 0 and square root of 0 is a 0. Our second problem is on the denominator. Denominator. Denominator can never be what? 0. Not x, okay? I'm not saying x cannot be 0. I'm saying the denominator cannot be 0. What do we have on the denominator? X plus 4. That means that x plus 4 cannot be 0. Not x. The whole expression, x plus 4, cannot be 0. Solve for x. What do you do? Minus 4. That means we can substitute x with anything on the denominator, but we cannot substitute negative 4. So denominator is saying if we have a negative 4, it cannot take negative 4, but it can take anything before negative 4, anything after negative 4. Now, on which interval do you see both conditions satisfied? Exactly. See, this one starts from 3, everything above 3. Here, it starts from everything left and right except for 4, but both of them have these conditions satisfied. I mean, this interval satisfies both conditions. Bigger than 3 and also not 4. So we take where they intersect. They intersect from 3 onwards. So domain is this. Start from 3 to infinity. Infinity always gets parentheses. And since we can substitute 3 with 0, sorry, x with 3, so 3 gets a bracket. Bracket means, yeah, we can use 3 for our x. But we cannot use anything smaller than 3. You cannot use 2. You cannot use 1. You cannot use 0. If you do, look what happens. If you say, well, I want x to be 2, no problem. Look what happens. 2 minus 3. Uh-oh. We have a negative 1 inside the root. It's not real. See? Even the 2 is bigger than 0, it's a positive number, but still we cannot plug in here. So don't look at x, look at the expression. Whatever expression we have inside our radical, that expression has to be bigger than 0 for the denominator. But it can be bigger than and equal 0 on the numerator. And it doesn't matter what do you have on the denominator, the whole expression cannot be 0. See here, if you want, you can actually substitute x with 0. You get 0 plus 4, which is 4. We are allowed to have 4 on the denominator, it's not a bad thing. But see, the whole expression cannot be 0. So to find the domain, the best way to figure out is think about what's wrong with your function. What is the problem? For square root, our problem is negative numbers, negative result. For denominators, our problem is 0. And then depending on other functions, you have other restrictions. Okay, any question on any of these? So try A by yourself, B I did, and question 2, I did both of them. And question 1, you did everything all by yourself. So if you're done, you can turn them in. If you're not done, bring it next class.